for this one, we're going to talk about section 4.5. And there really only is one thing out of section 4.5 that you would see on a test. There's really no example for it. So what I did in class was I did example 1 on page 225. And what they do is they give you this graph. And thank you to Alice for showing me that there's graph paper. So I actually have it drawn out how they have it in the textbook. So they have this graph and they say they want you to come up with an equation for if this is a sine wave and for if this is a cos wave. Now, the good news for this is that when we do this, a lot of the parts are the same if it's a sine wave or a cos wave. For instance, the number that goes right here, that is my amplitude. So remember that amplitude is your maximum minus your minimum divided by 2. So if I look, my maximum is 4, my minimum is -4. So it would be 4 minus -4 over 2, which would be 8 over 2, which would be 4. So my amplitude is 4. And it doesn't matter whether that is a sine wave or whether that is a cos wave, it is 4 regardless. Sorry, I have a dog sticking his nose in my work here. All right. So now let's look at B, what goes in this spot right here. Again, regardless of whether that's a sine wave or a cos wave, the same number is going to go there. Remember that B goes along with period. So because the x-axis here is in like just plain numbers, 1, 2, 3, that means that is not in degrees. If it's not in degrees, you have to assume radians. So the formula would be period is 2 pi over b. So what we want to know is b. So from the graph, we have to get the period. So to figure that out, there's lots of ways to do it, but personally, I like to look from crest to crest because that would be one wave. And so if I look, the first crest appears to happen at 0.5. The other crest appears to happen at 2.5. So how far is it from 0.5 to 2.5? Well, it is a distance of 2. So my period is 2. So that's equal to 2 pi over b. So 2b would equal 2 pi. Divide both sides by 2, and I get that b is pi. So where does it is? What would go here would be pi. And again, regardless of whether or not it's a sine wave or a cos wave, the period is the same. And so the b is the same. So I'm going to skip over the C. I'm going to skip over what goes in this bracket, and I'm going to look at vertical displacement, the plus D portion of the question. So the D is the vertical displacement. How much has it been moved up or down? So when we look at this, it says that the amplitude is 4, which would imply that the crest should happen at 4. And when I look, the crest does happen at 4, which means it has not been moved up or down at all. So there really isn't a D. If you really wanted to put something, you could put plus 0, but we don't need to. And again, it is exactly the same whether it's a sine wave or a cos wave. You could put, you could put plus 0 here if you wanted to, but there's no need. So that leaves us with the phase shift, the C. That is the only part that is different depending on if that's a sine wave or if that's a cos wave. So what I want to do is I want to look at sine first. Just a regular sine wave starts at 0 and 0 and goes up, comes down, and goes back up, right? That's what a sine wave looks like. All right, so this actually does that. It starts at 0. It starts at 0. It goes up and down and back up, which means it hasn't actually been moved at all. So again, there is no C. So this is technically, right here, that is the equation if that's a sine wave. Now let's think about a cos wave. A cos wave, I'll do it in blue. A cos wave normally starts at the maximum, goes down and comes back up. So where is that happening on this graph? That's actually happening here. It's starting at the max, going down and coming back up. Well, that is at 0.5. So someone has moved it to the right 0.5. So if that's a cos wave, that is the phase shift. And that's it.